Ever looked at a piece of code and just wondered, how does it work? How can a simple script seem so smart? Well, today, we're going to pop the hood on a language called TCL and build out your very first programmer's toolbox. This is where the magic really begins. Let's get into it.
Right? I mean, how does a program actually make a decision? How does it choose to go down one path instead of another, or know when it's supposed to stop? That's the big question we're tackling, and spoiler alert, it isn't magic. It's all about having the right tools for the job.
So let's open up this toolbox. The first thing you see in that top tray are all the small, essential pieces that do the real work. In programming, we call these the operators. They might look small, but they do all the heavy lifting.
So what exactly are operators? Well, they're basically special symbols that tell the script to perform a task. Think of them like the wrenches, screwdrivers, and tape measures of your code. Each one has a very, very specific job, whether it's doing some quick math or comparing two pieces of information.
And just like in a real toolbox, our tools are organized. We've got different types for different jobs. In TCL, this includes operators for basic math, for comparing things, for making logical decisions, and even some more advanced tools like bitwise and ternary operators. Let's take a quick peek at each one.
First up, we've got the ones you definitely already know, the arithmetic operators. Your classic plus, minus, multiply, and divide. Super simple. But right next to them are the relational operators, and these are absolutely crucial. They let our script compare two things and ask, is this bigger? Is this smaller? Are these two things equal? This right here is the very foundation of decision-making in code.
Then you've got logical operators. These let us chain conditions together, like asking if a number is greater than 10 and less than 20. Bitwise operators are a bit more advanced. They work directly on the ones and zeros that make up data, which is super powerful stuff. And finally, there's this cool little shortcut, the ternary operator. It's just a super compact way of saying, if this condition is true, do this thing, otherwise do that thing. A real space saver.
Okay, so we have our tools. But a pile of tools doesn't build a house, right? You need a plan, a blueprint. In programming, our blueprint is called control flow. This is what gives our script structure and tells it what to do with all those tools.
To put it simply, control flow statements are the commands that tell our script when and how to use its operators. They're like the traffic director for your code, telling it which path to take at a fork in the road, when to make a choice, and when to do something over and over again. This is how we bring a script to life.
So let's check out our first set of blueprints. These are all about making decisions. Think of it like your code arriving at a crossroads. Based on the information it has, it's got to choose a path to follow.
Let's start with a really common real-world problem. Imagine you've got a student's test score, and you need your script to automatically figure out their letter grade. How do we drop a blueprint for that?
The blueprint for this is the classic if-elseif structure. Let's say our student got a 75. The script first asks if the score is 90 or more. Nope. Okay, on to the next check. Else if the score is 75 or more. Yes, it is. So it runs that piece of code, prints grade B, and then it's done. It completely ignores the rest. It's a logical waterfall of questions, and this exact logic powers everything from login screens to ATMs.
Okay, but what if your decision isn't a range of numbers, but a choice from a specific menu, like, say, checking what kind of fruit you have? You could use a long chain of if statements, sure, but there's a much cleaner, much more elegant blueprint for this kind of job.
And this is where the switch statement is just perfect. It takes one variable, in this case our fruit, and compares it against a list of possibilities. It checks apple, no match. It checks orange, we have a match. It runs that code and then it's done. It's an incredibly tidy way to handle situations where you have multiple specific options, like choosing a character in a game or picking an item from a menu.
All right, our next set of blueprints. These are all about being efficient, working smarter, not harder. Sometimes you need your script to do the exact same task over and over and over again. Instead of writing the code 100 times, we use loops to automate the repetition.
Here's a classic programming challenge, finding prime numbers. To solve this, you basically have to run a check on every single number within a certain range. Doing that by hand would be awful, right? This is a perfect job for a loop, especially when we know exactly where we need to start and where we need to stop.
And the for loop is the ideal blueprint for this. Just look at its structure. It's got the whole plan right there in one line. First, the initialization. We start our counter at 2.
Second, the condition. We tell it to keep looping as long as our counter is 25 or less. And third, the increment. After each lap, we add 1 to the counter. It's the perfect tool when you know exactly how many laps you need to run.
But what if you don't know how many times you need the loop? What if you just need to keep going while a certain condition is still true? Let's take this problem, finding all the numbers up to 50 that are divisible by both 4 and 6. For this job, we pull out the while loop. This blueprint is way simpler. It only cares about one thing, a condition. Our code basically says, while this counter is less than or equal to 50, keep running the check. The loop only stops when that condition finally becomes false. It's perfect for when you don't know the exact endpoint, like waiting for a file to finish downloading.
Okay, one last repetition blueprint. This one might be my favorite. Imagine you have a collection of items, a list of names, a deck of cards, whatever, and you need to do something to every single item in that list. You don't want to mess with counters, you just want to make sure nothing gets missed. This is the perfect job for the for each loop. It's just so elegant. You give it a list, like our list of numbers here, and it automatically goes through each item one by one until it's done. No counters to set up, no conditions to check, it just works. It's the cleanest way to process every single element in a collection, period.
So there you have it. We've just put together your TCL starter kit. On one side, you've got your operators, the essential tools, and on the other, you've got your control flow statements, the blueprints that tell the tools what to do. So let's do a quick recap of which blueprint to grab for which job.
Think of this table as your quick start guide. It helps you choose the right tool for the job. Got a simple yes or no decision? Grab an if statement. Picking from a menu of options, switch is your best friend. Looping a set number of times? That's a for loop. Looping until something changes? Use while. And for hitting every single item in a list, nothing beats for each.
So, we've packed your first programmer's toolbox. You have the tools to perform actions, and you have the blueprints to give those actions structure and intelligence. The only question left is, what are you going to build first?